Alright, we have shown that there is some sort of relationship between the probability of E given F and the probability of E complement given F. They're as if it's just the probability of E and the probability of E complement. These are related to the axioms and theorems of conditional probability. So, for any event A, very similar to the axioms of probability in general, the probability of A given E would always be greater than or equal to 0. It can be an actual event that happened or an impossible event. Also, for a certain event S, which is the entire sample space, the probability of the sample space happening given that event E happened is also equal to 1. And if A and B are mutually exclusive, then the probability of A union B given E will just be equal to the probability of A given E and the probability of B given E. Further, extending axiom number 3, if A sub 1, A sub 2, A sub 3 are a sequence of mutually exclusive events, then the probability of the union of these mutually exclusive events given E would just be equal to the probability of the first event given E plus the probability of the second event given E plus the probability of the third event given E, and so on. One theorem is like what we saw a while ago. The probability of E given F plus the probability of E complement given F would be equal to 1. That would also mean that the probability of E complement given F is 1 minus the probability of E given F. So most of the axioms and theorems of conditional probability is still the same as of general probabilities. Remember, our idea of conditional probability is that it's still the same probability, but we just limited the sample space because an event already happened. Let's have another example of conditional probability. An urn contains 5 red, 6 brown, and 3 white marbles. Two marbles without replacement are drawn, meaning the marbles are not returned. What is the probability that the second marble is brown, given that the first marble is white? Pause the video and try to see if you'll be able to answer this question. Alright, so first of all, of course, as always, let's look at the sample space. So our sample space would be 2 marbles without replacements. So the cardinality of that set would be, on the first draw of your marbles, you're actually going to have 14, because that would be 5 plus 6 plus 3. That would be 14. And then once you draw your marble again without replacement, so that means the other marble is out, so you get 13. So that would be a total of 182 possible outcomes in our sample space. So let's take a look at the other probabilities of R2 events. Maybe this one first. It's better to always look at the condition as well. So the condition, the first marble is white. Well, I can't draw white here because this is white, so I'll just use this one. W, first marble is white. So if the first marble is white, that means you have 3 possible chances for that. And the rest can just be any other, which would be your 13. And that would be a total of 39 possible outcomes of having the first marble being white via fundamental principle of counting. So with that in mind, we also would like to know, given what's the probability that the second marble is brown. Although that's kind of difficult to look into, probably what we can look into instead is the number of possible outcomes that the second marble is brown and the first marble is white. Because anyway, that's what we're looking for. So, if the second marble is brown, given the first marble is white, here we have here that the first marble is white, you have 3 possible outcomes. Second marble is brown, you have actually 6 possible outcomes. So via fundamental principle of counting, you have 18 possible outcomes of having the second marble is brown, given that the first is white. So, based on the definition of conditional probability, oops, not E, but the probability that the second marble is brown given that the first marble is white would be that the probability that the second is brown and the first is white, which is 18, over the probability that the first marble that you got is white, 39. To be 18 over 39, or in simplest form or lowest form 6 over 13, or in percentage approximately 46.15% chance of getting the second marble brown given the first is white. If we're going to follow the formula, I'm going to write it in blue. The probability that the second marble is brown given the first is white would be the probability of having the second is brown and the first is white over the probability the first is white, which would actually be this one, 18 over 182, our sample space, all over this one, 39 over 182, which would still give us 18 over 39 and its simplest and other forms. Let's have another example. A man is dealt with 4 spades from an arbitrary standard deck of playing cards. If he is given 3 more cards, find the probability that one of those additional cards is also a spade. Pause the video and try to see if you'll be able to answer this problem. Alright, so let's analyze this one. A man is dealt with 4 spades already. So that would mean, out of the 52 playing cards, we remove the 4 spades and we get 48. If he is given 3 more cards, so that would mean we're looking into the fact that the man will get 3 more cards out of the 48. So that would mean that our sample space would actually be the combination of 48 taken 3, or it can be written as the combination of 48 taken 3. Those are the number of possible ways that the man will be given 3 more cards. And then we are asked find the probability that one of those additional cards is also a spade. Now, if we have removed 4 spades from a total of 13 cards, we actually have 9 cards left. So, we're asking what are the chances that we get an additional spade out of this one here. So, there are 3 cases wherein you can get an additional card is a spade. First of all, if all the 3 cards are actually a spade, so that's case number 1. And if all 3 cards, additional cards are spade, that would be the combination of 9 taken 3. If only 2 of the cards were a spade, that would be the combination of 9 taken 2. Then the rest would just be any other card, which would be now the combination of 39 taken 1. Now, take note that this 39 came from the fact that there are the other 3 suits. That's 13 times 3. Diamonds, hearts, clubs. Choose one from them. And if there's only just one spade, that would be the combination of 9 taken 1 times the combination of 39, taken 2. And you add all of that to get the total possible outcomes out of the fact that we're going to give 3 additional cards. So therefore, the probability that one of the additional cards is a spade, one additional cards is a spade, I'll just use that symbol, given that there were already 4 spades dealt, would actually be the probability of this long here combination of 9 taken 3 plus the combination of 9 taken 2 times the combination of 39 taken 1 plus the combination, the combination of 9 taken 1 times the combination of 39 taken 2 all over the combination of 48 taken 3. Oops, we don't have space. This would actually be equal to a fraction 8,157 over 17,296, or in not decimal but in percent because it's easier to understand, 47.16%. So you have an almost half chance that the one of the three additional cards will be a spade. Those are examples of conditional probability.